Welcome to another coding tutorial, and in today's video I'm going to show you how to make this game of life clock. The plan for today is that first we'll be drawing the digital clock, and we can do that using the clock functions within p5.js to get a real-time clock data. And then we'll be using the function textToPoints to get an array of points that outline a string of text. And then we'll be making the game of life, and at the end we'll be combining all of these concepts to get the effect that you see right here. Since we're combining a bunch of different concepts, if you want to get a better understanding of each of the concepts, I recommend you check out my other videos, which I will link down below. Let's start by creating a digital clock. First, I'm going to show you how we can get the clock data within p5.js using three main functions: hour, minute, and second. Why don't we start by printing out these functions? So hour, minute, and second. And as you can see here, it is currently 11, 14, and 33, 34 seconds, right? So with these three functions, we can get the real-time clock data. Now, we want to be able to draw these string of numbers onto the canvas, and we can do that using the function textToPoints. To use the function textToPoints, first we need to upload a font, and we can do that by coming to this arrow here. You can upload the font directly to this directory, but what I want to do first is to create a folder called fonts. And then within this folder, I want to upload a file, and then this is where we'll be putting in the font file that we have. You can just drag and drop your font file into here, and then once the file is uploaded, now it is in this folder font. What you want to do next is that we're going to be using a function called preload to preload the font onto the sketch. And so first we need to also declare a variable called font, and we're going to set this font to another function called loadFont. And then inside this parentheses, the argument that you need to put in is basically where your font file is, and in my case it is in a folder called fonts, and the file name is called roboto-regular.ttf. So that's exactly what we're going to put inside here. And we also need to put two quotation marks here, and then we do fonts /roboto-regular.ttf. All right, and then I'm just gonna click run just to make sure that there's no error, and there's none. All right, I'm gonna comment this timeout as well. What we want to do next is that we want to create an array, and I'm gonna call it points. This is gonna be the array that we want to keep the array of points that outline the string of text that we want to write on the screen. Then inside setup, we're gonna set the points array to a function textToPoints, and we can do that by first writing the word font and then dot textToPoints. And we need to put font first because textToPoints function is a method within the p5 font class. The textToPoints function can take in a total of 5 arguments, 3 of which are required, the first 3. The first argument is the string of text that we want to get the array of points. The second and the third are the x and y position of the bottom left corner of the bounding box of the text that we're going to write. So how about we first declare all of these argument variables. So first is the string of text. I'm going to call it a message. How about we call it, we just say hello. And then the x position and the y position, which are the position of the bottom left corner of the bounding box. How about we set it to 0 for both? And then we need font size, which I'm going to set at 150. Then what we need to do is that we need to put in all of these arguments. All right, and if I click run now, nothing happens. So how about we start by just printing out what is in the points array. So as you can see here, we have a bunch of objects, 238 objects inside this array, and inside each of the objects we have the x and y coordinates and alpha. The two important data that we want is the x and y coordinates of each of the points. All right, and once we know that, we can basically in the draw function use a for loop that go over from I equals to 0 to I less than points.length. This is the length of the points array, right? And then we can basically just How about we draw an ellipse, which takes in a total of 4 arguments. The first 2 are the x and y coordinate of the center of the ellipse, right? So let's do points of I dot x, points of I dot y. How about we set the size to 10? And let's just click run. All right, so as you can see here, we can kind of see a bunch of circles here. But as I said, the x and y position is the bottom left corner of the bounding box, right? So that's why we don't really see the circles here. So how about we just move the y coordinate down to, how about 250? All right, so we can see the word hello. I'm also actually going to set my canvas to a bigger size. But we don't want to actually write the word hello, right? We want to write the clock data on here. So instead of setting it at hello here, we will actually, first we need to move the points data here into draw, because the points data will be updating every single time the clock is changed, right? And then now what we want to do is actually we want to set, how about we first just set message to be equals to hour. Let's click run. And that doesn't work because it takes in a string of text, but hour actually returns an integer, and we can change the type from integer to text using a function called toString. So how about we set h message to be equals to hour dot toString, and then we need to set message to each message, right? All right, and now because it's at 11 a.m. and that's why you just see 11 without it changing. So how about if I change this to s instead of hour, we will do second. So now our points array is updating every time the time updates. Oh no, but as you can see here, when the time is only 1 digit, we only get 1 number displayed. But that's not what we want. We want to be able to display 2 digits at every single time, so we have a consistent look of the text on the canvas. And we can do that using a conditional statement that tests whether our string of text is of the length 1 or 2, right? So let's do that. So if s.message.length, actually how about we print this first just to see. We need to put this after here. So let's print this. It's 2 and then 1, right? Did you see that? So right now it's 1, that's the length of it. And then once it hits 10, it would just become 2. Perfect. So now we'll just use this as part of our condition. So we just say if s_msg dot length is equals to 1, so it's only 1 digit, then we want to set the message to what? We want to send it to 0, and then we want to add s_message, right? Else, then we'll just set message to s_message. We don't need any of this. So how about we try to print it again? Yay! All right. So now it works. But we want to do this for all hour, minute, and second. So I'm going to actually write a function. And this function is going to be called double digits. And it's going to take in an argument. How about we call this argument integer? And we're going to set a variable called int toString. And it's basically is going to turn an integer to a string, right? Using the function toString. Then we're just going to use the conditional statement that we created here. Let's put it here. All right, first I'm going to declare a variable called message, and then instead of s_message here, it's going to be int toString, right? So it's going to be this one dot length. If it equals to 1, then we're going to set the message to 0 plus int toString. Else we just set it to int toString. All right, so we have this function. Then how about we set 3 more variables, 2 more actually. So we already have s_msg. We're just gonna do h_msg, set it to double digits, and what we want to put as an argument will be hour, right? And how about we just do this 2 more times? I'm gonna delete this. All right, so this will be minute, and this will be second. And then our message is going to actually be combining all these 3 strings. So it's going to be h_msg plus m_msg and plus s_msg. All right. And text.split is not working. What did I do wrong? So integer to string. Oh, I forgot to return the message. So let's click run again. All right, so now we have a clock. So it's 11:33:32 seconds. Let's just add a little bit of a colon in between. So we'll just do this in between our minute and second. So all right, so maybe off screen, so let me just show you what it's like here. Perfect. All right, so now I'm also going to move it a little bit to the right. So how about I move it by 35? Okay, so now it's in the middle. Now that we can draw the digital clock on our canvas, let's make a game of life. First, how about I label this as clock variables. Then now we're going to create a game of life. And first, we're going to do that by creating 3 variables, columns, rows, and size. So these are going to be the variables for our grid. Let's set the size to 10. And then I'm going to also declare an array called grid. So inside setup, we're going to calculate columns by dividing width by size, and then rows by dividing height by size. Then I'm going to use a nested for loop to populate my grid. And the grid basically is going to keep the data for the state of each of the cell in the game of life, right? So inside the outer loop here, first I'm going to populate my grid array with empty 1D arrays, and then we're going to make it a 2D array. So inside this inner grid, I'm going to give the data everything as 0. So for the state of each of the cells, 0 means it's dead, and then 1 means it's alive. And we'll be using this data to draw out the grid. So how about we also write a nested for loop within the draw function here. First, I'm going to draw out a bunch of squares using the rect function, which takes in a total of 4 arguments. The first 2 are the x-coordinates of the top left corner of the square, and then the third and the fourth are the width and the height. And then we can just do I times size, j times size, and then size and size because it's a square. Let's click run. All right, so now we have a bunch of squares in rows and columns. And we're going to use the data from the grid array to color our squares. So I'm gonna write a conditional statement that says if grid of, actually it's going to be inside here. So if grid of I and j is equals to 1, meaning that the cell is alive, then I want to color it black, else color it white. And you will see that everything is going to be white because we have set the initial state as 0. So how about we just randomize it between 0 and 1 by using the function floor and give it an argument of random of 2. And then now we have a bunch of random life. Now we only have one generation of our cells, and we actually want to be able to update it over time, right? The states of the cells will evolve over time based on the states of its neighboring cells, so the 8 cells around it. First, I'm going to write a nested for loop. For us to update the next generation of cells, we need to have another 2D array. So I'm going to declare it as next gen, set it as an empty array, and just like what we did with grid, first we need to populate it with empty 1D arrays, and then inside the next gen 2D array, we're going to give it a new state of the next generation. And as I said before, the new state depends on the states of the neighboring cells. So how about we write the function called neighboring states that sums up the states of the cells around the cell that we want to calculate. So we're going to give it 3 arguments. So the grid, an x and y location of the cell that we're evaluating. So inside this function, we want to loop through all the cells that are the neighbors of the cell we're evaluating. So we're going to use a nested for loop to do that, but it will only go between I equals to -1 to I less than 2. Same thing for rows. So from -1 to j less than 2. And then we're going to sum up the states, right? So first I'm going to declare a variable called sum, set it to 0. And then sum is going to be a sum of all the states of the 8 neighbors. But because of this nested for loop, we will be summing all the 9, including the one we are evaluating first. So let's do grid of x plus I, and then of y plus j. All right, and then at the end, we need to subtract out the grid in the middle, right? Because we don't want the state of that particular grid. But providing the index values this way will give us some errors for some corner cases. So what we need to do is that we need to be able to wrap around the values. And we can do that using this trick. So I'm going to set x index to x plus I, and then we're going to add the number of columns, and then using the mod function, columns. Same thing for the y index equals to y plus j plus rows. Then we're going to use the mod function for rows. Then I'm going to fill in this as x index and y index. And I'm going through this very quickly, but you can check out my Game of Life video where I go into why we need to use this to fix these corner cases problem. All right, and then we do not want to forget to return the sum of neighboring states. All right, so inside now the next gen 2D array, first we need to declare a variable called n, and we're going to call this neighboring states function, right? Put in the grid, which is the grid that we see here, and then instead of x and y here, it's going to be I and j, right? So now we have the value that is the states of the neighboring cells. So then we can write a conditional statement that will set the state of the cell in the next generation. So we have a total of 4 rules. So the first one is that any live cell with fewer than 2 live neighbors dies. Second one, any live cell with 2 or 3 live neighbors lives. Any live cell with more than 3 live neighbors dies. And any dead cell with exactly 3 live neighbors will become a live cell. All right, so we have a total of 4 rules. So first, if grid of I and j is equals to 1, meaning that that cell is alive, and n is less than 2, then we'll set the next generation to dead. And then the second one is if grid of I and j, so if it is an alive cell and n is equals to 2 or n is equals to 3, then next gen of I and j is alive. Else if grid of I and j is equals to 1, meaning it's alive, and n is greater than 3, then next gen is dead. And then the fourth one is if grid of I and j is dead and n is exactly equals to 3, then next gen of I and j is equals to 1. Then I'm just going to set the last one just in case to include everything, that next gen will be equals to the current value of grid of I and j. All right, and outside of these whole nested for loop, so first we basically draw the game of life, right? And then we set the next generation in this next gen to the array. And then outside here, we want to set the grid, which is the current generation, to the next gen to the array, which is the next generation. Then it keeps updating over and over again. All right, let's click run. And there you go. We get a working self. All right, so if we go back to here, we can see that I have set the initial condition as random values between 0 and 1, right? So that's not what we want to do. We want to actually set the state of each cell to be the values that we get from the clock data. So how about we set this back to 0 first? And what we can do is that we're going to uncomment all of this. And then, okay, before we do anything, I want to actually also set another function called drawPoints, and I'm going to put in these ellipses here inside. All right, and then we can just put drawPoints here. Okay, so let's just click run and see what happens. Okay, we don't see any points here, so I'm going to put drawPoints actually after we draw the values here. So how about we also make this black? Okay, so now we have a grid of cells and we have our clock data. So I want to be able to set the states of the cell based on the clock data that we draw on the canvas. And we can do that by actually coming to this nested loop here where we draw the grid. After this nested loop, we're going to write another for loop that actually is going to loop through the array points. So let k equals to 0, k less than points dot length, k plus plus. What we're going to do is we're going to figure out the distance between the grid and the points. And if the distance between these two things are less than a certain threshold, then it means that we're going to set that cell to 1, then we're going to fill in the color black, right? And else, then you stay white. We first going to declare a variable called distance, and we're going to set distance to a function called dist, and dist is a function within p5.js that calculates the distance between 2 points, and it takes in 4 arguments, which are the x and y coordinates of the 2 points. So the 2 points that we want to calculate between is the x and y coordinates of the points on the string of text, right? So points of k.x and points of k.y. And it's going to be each of the cells, right? Which is, how about we let x to be equals to I times size, right? And then y is j times size, which is the top left corner of each of the square. And these are going to be the values that we put in as the third and the fourth arguments. And then what we're going to do is we're going to say if distance is less than a certain threshold, how about we say 10, then we're going to set grid of I and j to be 1. And that's it. And then if we click run, do you see that? Now, if I comment out draw points. Then now we can see a clock in a grid form. Perfect. And I'm also going to, how about just make a variable here called distance from points and set it as a variable that we can change here. Let's do let distance from points to be equals to 10. Okay, because if you increase this, let's do 20, then we get like a bigger, darker color. So if we do, how about 3? So we cannot really see it as a number anymore. So you can switch around, because if you were to change the font size and things like that, you need to adjust everything. I'm going to set it to 10 for now. Now let's change some colors. How about that? How about we do the background to be black, and then I want to actually do no fill, and then just say that if grid is equals to 1, then I want to set the stroke to white. Else we want to set actually no stroke. Okay, that's nice. All right, so now I want to actually just draw the clock in a rainbow color, and I can do that by actually creating another 2D array that actually does the exact same thing that grid currently does. So what I'm gonna do is that I'm gonna come here and then just set another array. How about we call it clock? And this is a little bit tedious, but we're basically going to do the exact same thing that we do for grid here. So we're gonna fill everything in as 0 for now, and then inside here we're just going to, if the distance is less than distance from points, then clock of I and j will be equals to 1, and then we're going to draw the clock on top actually. And then how about we set this to red for now, just to see. So if clock equals to 1, then we'll draw it as red. And the reason that I have to create another 2D array is because I don't want to update the grid. I don't want it to actually go through this next gen, like updating the next generation, right? But as you can see here, this is not really, can you see this? It might be off screen. But if you look at the seconds part right here, you can see that it's not really a number anymore. And that is because we need to also set the array back to 0 every time it is updated. So basically outside of this conditional statement, I want to set clock of I and j back to 0. So, all right, so as you can see here, you can see the numbers updating. Before, it kept continuing to have the value of 1, so it's being drawn over and over and over on top of each other, so you couldn't see the numbers. So now it works as we planned. So now let's make it a rainbow color, and we can do that by, first we're going to come to setup, and we're going to set the color mode to the mode called HSB, which stands for hue, saturation, and brightness, instead of our default one, which is RGB, where we put in the value colors for red, green, and blue, right? So we can use the function called color mode and then change the mode to HSB. Then we want to set another variable called hue value and set it to 0. All right. And because the mode is now at HSB, we're basically just changing the argument hue, right? So what we need to do is that instead of setting the clock color here to be 255, 0, we want to do hue value, 255 and 255. And that is because the second and third one are for saturation and brightness, and we want to set that to the maximum. And if I click run now, I get the color red, because when hue equals to 0, you get the color red, basically. Now, to make it a rainbow color, all you need to do is, how about we come to the bottom here of the draw function and just said we want to increment hue value by, how about 5. All right, so now it changes from red to, now you can see green, and you can see blue, then you can see a darker blue, and then you can see purple. Okay, so the hue value will continue to go up and up, so we need a conditional statement that say if hue value is greater than 255, then we'll set hue value back to 0. And I'm actually not sure if the default value for the maximum of this cycle is 255 or not, so I'm going to also provide a second argument within the color mode which sets the maximum. So basically, if I put in 255 here, then the value will go between 0 and 255. So now we know that this is the maximum, 255. So if I click run, then now our clock changes from red now to green, now to blue, now to purple, pink, and go back to red. All right, and it's exactly 12 o'clock. Perfect, good timing. So now you can see how to combine different concepts to make this pretty cool looking clock. It reminds me of Tetris. So give this one a try.